Hello everyone, this is the third question of the Deep Learning Important Questions Simple Answers series. What is the role of activation function in deep learning, and briefly explain its types. To answer this question, first of all, let's look at the neural network architecture. As you see, we have different layers in neural network like input layer, hidden layers, and output layer. And each neuron in the hidden layers and output layer has an activation function. Let's look at a neuron closely. So as you see, we have some inputs, and each input has its own weights. We can have 1 to n inputs and 1 to n weights. And for each neuron, we have a 1 bias. Remember, we will multiply x1 and weight 1, x2 and weight 2, then we will get the sum of these results. Then we will get the sum of each multiplication, and the result of that will be an input to our activation function. So this is the formula of the first part, xi times weight I, and 1 bias for each neuron. And the output, y equals the result of activation function. And this part will be the input of the activation function. But what is activation function? If we look at the definitions, we will see that activation function defines the output of neuron. Or we can say activation function decides whether a neuron should be activated or not. So it's basically a mathematical function. Of course, there are different types, and they are quite important in the neural network structure. Let's look at them. These are the major common ones: linear activation function, binary step, sigmoid, 10H, ReLU, and more. Let's look at them one by one. So this is the graph of linear activation function. As you see, the output is exactly the same with the input. If your x is 0, then y is 0. If your x value is 4, then y will be 4. Or if your x is minus 4, then y will be minus 4. Therefore, sometimes linear activation function is called as no activation function. Especially in regression problems, we will use linear activation function. And the second one is binary step function. So this is the graph of binary step function. As you see, for the negative values, output will be 0. And for the positive values, output will be 1. So binary step activation function generates two different outputs, 1 or 0. So because of this structure and only two outputs, binary step function is not very common in modern neural network structures. And the rest of them, sigmoid, 10Hash, and ReLU, they are quite popular and mostly employed activation functions in a neural network. So this is the sigmoid function graph, and this is the 10Hash graph. They are quite similar, they are smooth, but output of sigmoid function is between 0 and 1. However, in 10Hash, it's quite similar, but the output values between -1 and 1. Because of their similar structure, they can cause vanishing gradient or exploding gradient problems, but also their smoothness is good to prevent overshooting in the gradient descent. So they have some advantages and disadvantages, and one of the biggest disadvantages of these functions is they are expensive in terms of computation, especially comparing to the ReLU or linear activation function. And this is the graph of ReLU, rectified linear unit activation function. As you see, for the negative values, the output value will be 0. For the positive values, output will be like linear activation function. If you give 4, then output will be 4. If you give 1, the output will be 1. So in terms of computation, it's quite efficient, and especially in hidden layers, the ReLU is one of the most employed activation function. But how to decide? How can we decide which activation function for which neuron? Basically, we can say that the position of the neuron is quite important, because if it is in the hidden layer, then ReLU is the mostly employed activation function, but of course, according to problem type, it can change. Position of the neuron is quite important because the neuron is in the output layer, and the problem type is regression. then the activation function can be linear activation function. But for the classification, if it is binary classification, then sigmoid. But if it is multiple classification, then softmax, another activation function, can be used. So before the decision, you should consider the pros and cons. The computational cost, there can be some problems like vanishing or exploding gradient or dying ReLU. So you should understand the advantages and disadvantages of activation functions. Because they are quite important, they affect the model's performance, the success, and also computational efficiency. So that's all. This is the simple explanation of the role of activation function in deep learning.